So we're on worksheet 6. We're going to talk about logarithm properties today. But first, let's recall a couple exponent properties because exponents and logarithms are inverses of each other. So when you have an exponent problem where you're trying to multiply the bases together, the way you do that is you add the exponents together. Similarly, with quotient property, you subtracted the exponents, and then with power property, you multiply them together. So that's great, but those are exponent properties. How do those translate over to logarithm properties? Well, they do. They directly translate over to logarithm properties. Where is my pen? Right here. Let's talk about these properties, guys. So if you have what's called the product property, so within a logarithm of any base, whoopsies, you have a multiplication problem. You can expand that into log of the first thing plus log of the second thing. Remember doing these expanding problems last year a little bit? We'll see some examples in a minute. All right, quotient property also has its own set of rules that if you have a logarithm with a division problem inside of it, you can expand that into log of the numerator minus log of the denominator. And then the power property, which actually is the whole point of logarithms, says that if you apply a logarithm to something with an exponent, that exponent gets located back down in front like a coefficient. So people who had me for Algebra 2, we called that the Mario property. We're not going to get into that in PreCalc. But I will give you a little rundown as to why this property works, guys. Let's see a really boring example of common log of x squared. So without knowing the power property, what you would have to do to expand this is to remember what x squared means. Essentially, what does x squared mean?
X times x.
X times x, yes. So this is really common log of x times x. So we're looking at this product property. So according to my teachers, when you have log of a multiplication problem like this splits into log of the first thing plus log of the second thing. Well, think about what you have here, guys. You have log of x plus another log of x. You have two identical things that you're adding together. So doesn't that just mean you have two of them? So you have 2 log of x? So the power property is just a shortcut. So instead of writing a whole bunch of x's out or a whole bunch of y's out or whatever you have, it skips all this product stuff, and it says just bring the 2 down in front, because that's how many logarithms you're going to have in a minute. So it's a shortcut, essentially, is what it is. All right? So let's take a look at some examples. This is on your notes now on worksheet 6. These are not on your notes, though, so you're just going to watch with me. Let's talk about how we can expand these logarithms. So first of all, what does this 8 mean? It's a little subscript. It's the base, so it's the type of logarithm you have. So as you expand this one out, you just have to keep writing log base 8. You guys don't have to write this one. You can just watch it. But notice inside of the logarithm, I don't know about you, but I'm seeing 2 of the properties that we just discussed. Do you see 2 different properties? I see product. Do you see another one? There is a power. But is everybody being raised to that power? No. So we got to hold off on the power property for now. Let's split up the product property into not 1, not 2, but 3 logarithms because there are 3 things being multiplied together. So you have log base 8 of x. Now these parentheses that I'm using are optional. I just really like them because it tells me that you guys understand that this is a log function who's surrounding the x. All right, plus, that's how the property works, plus log base 8 of y plus, very good, log base 8 of z squared, which Daniel already told me he was anticipating this 2 getting written down in front of his logarithm. So in Algebra 2, a lot of kids have to do this in stages, and that's fine. And it's even fine for PreCalc, especially on a test when you're nervous about whether you're making a mistake. But as you guys get more comfortable with these, I would like to see you guys taking a little more risk and saying, I think I can expand this in 1 step. So now I have to rewrite everything. Log base 8 of x plus log base 8 of y. And then we have 2 of these log base 8 of z's. So that's what it looks like to expand a logarithm. The rule for how do you know if you're done? Every logarithm can only have 1 thing inside of it, and that includes exponents. So there can't be any multiplication, any division, or any exponents. If there still has one of those inside of a logarithm, you're not done expanding it. So let's take a look at this next one. Log base 6. Yes, go ahead.
So what if you had like a coefficient in front of the logarithm, and then you also had a power property?
So those, okay, I got what you're saying. So if you had something like 3 log x squared, there already was a 3 there?
Yeah.
Well, technically, this 3 belongs up here. So this is really log of x to the 6. So either way, if you bring the 2 down,
bring the 2 down, it's a multiple.
yeah,
Okay.
that would be like a half-done problem.
Okay.
which you could have at some point, I suppose. All right. So this one, I'm seeing two properties again. I'm seeing quotient this time, and I'm seeing power, but do you notice while they both have powers, they have different powers. So you got to kind of hold off on taking the powers down. So quotient says you're supposed to take the numerator first. So log base 6 of the numerator, and you're supposed to subtract log base 6 of your denominator. But why would one argue that this is not fully expanded?
You have to get rid of those.
No, these powers. There's too many things inside of each logarithm. So this power has to come down in front of his logarithm, as does this one. And if you guys could have done that in one step, that is amazing, and I'm very happy for your fluidity in math. 4 times log base 6 of x minus 5 times log base 6 of y. Okay, I know I should be the last person to be picky about this, but I am going to be picky about handwriting on this one. The base 6 is tiny, it's a subscript, it's small. It's below the level of the logarithm in your text, okay? I get kids who write things like this to me. And I'm supposed to know that that was a base 6.
What if I put the x in parentheses? Then do you know that it's base 6?
Not really. Because it could be 6 times x. The nature of that is a little weird. So you need to just make sure that you're careful that your base numbers are small. They're subscript. I would like you guys to think about using parentheses if you feel like, man, I have bad handwriting. Like, I have bad handwriting, so you'll always see me using parentheses unless I get uber lazy. But that's just one of the things we got to work with. All right, let's take a look at an example. Notice the directions here. It says evaluate. This is a good candidate for your test from Wednesday. And remember, it's no calculator, so don't you dare touch that calculator. So you might be wondering, how is she going to ask me to evaluate this without a calculator? Well, pretty easily, actually. The 3, just leave it alone for a minute. And let's talk about this problem right here. We've got log base 2 of 8. With our work yesterday, you guys should be able to evaluate that if you were to change it to an exponential problem. So this exponential problem looks like this. 2 to what mystery power gives you an 8? And then you think for a minute. Without a calculator, it's 3. So this really says 3 times 3 right here. Plus 5. And then let's hold off on a minute. Right here, this is something you can do in your head. 2 to what mystery power gives you a 4? It's a 2. So this problem really says 9 plus 10, better known as 19. So this is the kind of stuff we're going to make you do on Wednesday, okay? And if you're like me, you're going to screw up on 3 times 3 and call it 6, because that's the kind of stuff I do. Okay, so just be careful that you're executing the logarithm properties properly, but you're also careful that you remember how to multiply and add. That's that too. All right, this next one's already done for you, so let's just kind of look through it and highlight the important parts. First of all, could someone talk to me about what that says right there? What kind of logarithm is that?
It's a natural log.
It's a natural logarithm. All right, natural logarithm of, man, guys, I see every single property here. I see quotient, I see some product, and I see powers. So the property that has to be taken care of first is typically quotient, because that's involving all of the terms. So that's what they did first. They took the natural log of the numerator, and then they subtracted the natural log of the denominator. So within the numerator, they have more properties. So it said this is 8 times x to the 5th. So that's how they split up natural log of 8 plus natural log of x to the 5th. And then they split up this natural log, because again it's 3 times y to the 2nd. But look what they did. Very crafty of them. Remember how this was subtracted? Because everything that follows is supposed to be in the denominator of that logarithm. So look what they did with the subtraction sign. Instead of saying it's subtracted natural log of 3 plus natural log of y squared, which is how they broke up the multiplication problem, they went ahead and they distributed the subtraction to each logarithm. And a quick way to double check that you've done that part right, guys, everything that has a subtraction sign in front of their logarithm, that means that that term is located in the denominator of the original logarithm. So, feel good with what we've done so far. The last thing they did then is they took the powers and they brought them down in front of their logarithms. So, that's how they ended up with their final answer. That was an involved question. That had a lot of terms. And a fun thing that you could do to kind of quiz yourself to see if you really understand what's going on, before you start a problem, decide how many logarithms you're going to have when you're done. before you touch pencil to the paper. So like at the very beginning here, would you be able to look at that and tell me you're going to split this up into 4 logarithms?
Yeah.
That's good. That's good news. It means you're on the right track, okay? All right. So these are from your textbook. You can just kind of watch me work with these. They don't have any instructions. I think they wanted me to evaluate them. So I'm just going to make up my own instructions. These would be great questions to practice for our test that we have next week. So log base 6 of the cube root of 36. Now, the cube root, that's a curious way to think about log and exponent properties. We wouldn't really think of this as a cube root. Maybe you could change that to a power for me.
1/3.
Yeah, this is really 36 to the 1/3 power. Very good. So why does that help me? Well,
No, that looks pretty.
kinda. Because I like this. What's this? This is 6 to what power gives me a 36 is what it's asking you.
The power of 1/3.
So this
Wait.
this bubble
Yeah.
is a 2. But this bubble is raised to the 1/3 power. So you're probably thinking to yourself like, well, now what? That's kind of it. The answer is cube root of 2. That's a weird question. I wouldn't put that one on your test. The one that we're going to look at next, this looks like more like one that's on your test. Okay, think about your work. Are you wondering if the third drops down
How you get to
to the green thing?
Yeah, I don't get how you go from the original problem down to the cube root.
So I rewrote this as the 1/3 power, which you told me to do, right?
Mm-hmm.
This log base 6 of 36 is equivalent to this problem. I can't think of a logarithm, but I can totally think of this. So it's saying like 6 to what power is 36, and the answer is 2.
Oh,
So this green bubble is a 2.
Okay.
Okay. And then it already had a 1/3 power on it, so cube root.
Because it would be. Yeah, I got it.
Yeah, we could have also written it as log base 6 of 6 squared to the 1/3 power.
Yeah, I was forgetting about like it was like equal to thing. Very.
I got you.
had to solve for that.
I feel like I screwed something up though just now. Hold on. I did. Back up.
Aha.
Haha. It's not this at all. Didn't the 1/3 drop down? Aha. Oh, kids. All right.
Huh?
I don't know. Let's look. I'm going to look at this version for a minute. Yeah, no, I'm good. I got you. Log base 6 of 6. Guys, what do you do with exponents when they're like this? Yeah. So, this is really 2/3. This is 2 times 1/3 right here, right? Am I reading my own handwriting properly?
Yeah.
So 2 times 1/3 is 2/3?
Yeah.
Do you guys see what I did here? I changed 36 for a 6 squared.
Yes.
I caught myself. I made a big mistake. And I was about to lecture you all on possibly making the same mistake, and then I went ahead and made it. How is that for karma? Okay, watch what happens here, guys. Log base 6 of 6. Tell me what happens when your bases match like this. You cancel, and your answer is 2/3. So I made a mistake back here. This 1/3, like I kept it up in the exponent, but it wasn't in the exponent anymore. It's going to drop down. There's no longer a logarithm here anymore, right? It was just 2 times 1/3. So either way, we're going to get an answer of 2/3. That was my bad. I screwed up. And I screwed up in first hour, and those mutes didn't tell me.
Yeah.
First hour. Jeez. You know, they tried. They tried for a little bit. Okay, 2B. This is more of my style. Okay, this is something that I might see in my no calculator test for sure. Natural log of e to the 9th power. What happens when you apply a natural log to a base e problem like this?
Oh, they can't.
They cancel out, right? So I'm going to learn from my lesson here, guys. The 9 is going to drop down.
Yes.
And then here, the 4 is still there, but then the natural log and e cancel, and the 3 drops down. So you got 9 plus 12. Children, you have a 21. What?
Read it from October.
All right. So we have 21. Okay, back to your notes. Finally, you get to participate in this fun. I want you to evaluate this, which means I'm looking for a nice, pretty answer. I'm going to pause the video. I'm going to freeze the screen.
I got 2.
So the answer is supposed to come out to 2, and my wonderful second hour right now is thinking very hard about why the answer is 2. Maybe they're fixing each other's mistakes if there was one. Here's what my work looks like. Maybe your work looks a little different. But that's what I came up with.
Yeah, that's
exactly where your brain was at. I love how you take your notes in your head. That's such good practice. That's being sarcastic, by the way. You should be taking your notes.
Alright. You don't want this all up on your
I don't.
YouTube channel. So
I
I'll
don't.
tell you after class.
That's fine.
About the
The research that you've done.
Listen to.
Alright. Let's take a look at number 2. So, directions change. I give you a really nasty logarithm, and I want you to expand it. So, anybody have any thoughts as to how many logarithms we're going to break this up into? There's going to be 3 logarithms, and they're all going to be base 3 logarithms. All right. So, y'all have a little bit of work to do here. One of the things I might suggest you do, if this was on a test, maybe don't do it all in one step. And this is your notes, right? So, it doesn't really make sense for you to do it all in one step. I know in your homework you might get a little brave and try to do it all in one step. I gotcha. Just check that you're doing them right. As I'm rewriting the denominator though, the minus log base 3 of, instead of the cube root of t squared, I'm going to rewrite that as a fraction exponent. So t to the 2/3 power. Clearly this is not done though. This first logarithm, for instance, has a multiplication problem in it that we're going to need to split up. And then this second problem here has an exponent that will eventually need to come down. So now maybe I'm getting a little brave. You know, it's my second time around doing logarithm expansions. Maybe I'll try to do this one in one final step. So log base 3 of 5. And then you're going to add it to, this will be log base 3 of r to the 5th, but then Daniel's telling me I got to bring the 5 down. So I'll go ahead and do that. 5 log base 3 of r, good. And then while we're bringing exponents down, let's bring that baby down. 2/3 log base 3 of t. Very nice. So I kind of do a quick run through and I make sure there's nothing left in one of the logarithms that can't be there anymore. Everybody has one thing inside of it. All the exponents are down. I'll be honest, I don't love expanding logarithms. I really am very good at mentally condensing logarithms. So if I was on a test, I might quickly collapse it back together and see if I end up with the same answer again that I started with. It's an option. All right, let's try number 3. Number 3 looks really complicated. It's actually easy. It's a bit lengthy once you write it out. Now, I will caution you on number 3. At no point do I want you polynomial expanding. So like b plus 4 to the 6th power, do not multiply that out. That is a horrible question. You're just going to take your exponent and you're going to move it in a minute, okay? So no polynomial expansion. You're just doing logarithm expansion. I'm going to freeze the screen. I'm going to pause the video. Try it. All right, they're trying. I can see them totally trying. And when this guy got expanded, it broke into not 1, not 2, but 3 logarithms. And 2 of your logarithms have coefficients because exponents came down. Let's see. Did you get that?
Oh.
Yay! Look at you.
I understand what I did wrong.
What did you do wrong, Daniel? This is a good moment for us. What came up?
I didn't separate the polynomial.
Oh! Like
Because
the original numerator?
Yeah, you were sitting there thinking, you keep saying don't touch the polynomial.
Like don't expand it.
So yeah, so I'm sitting
But
here, I'm like,
essentially
all right,
that is a multiplication question,
yeah,
right? Yeah, I got you.
I understand.
So there's going to be something kind of like that on your no calculator test. So
half done.
you're almost there.
2/3 done.
That's true. To be technical about it. All right, let's take a look at condensing. So these are just examples I want you to watch with me. I much prefer condensing logarithms. I think they're easier. They're much easier to do in one step. And frankly, they just look better because it's condensed. So at the end of this problem, you're going to have log base 2, and it's going to have some stuff inside of it. Now, I would not bat an eyelash after the next 5 minutes. You guys are like, I can do this without showing work. Cool. I'm with you. I think you should be able to do this without showing work. And possibly the expanding ones as well. Of course, this is PreCalc, so you know we're going to give you some crazy ones coming up. All right. So one of the things we're going to have to do is the exponents have to go back up into the exponent position. So maybe mentally and maybe not, you're rewriting this as log base 2 of x to the 12th power. plus log base 2 of y to the 6th power. That is not condensed because this is what I like about condensing. Clearly you're done when you have one logarithm. So bringing them back together into one logarithm, if you're trying to add those logarithms together, you take your inside pieces and you multiply them together. So this becomes x to the 12th times y to the 6th. And that's when I know I'm done. The logarithms are all back together. It's called condensing. So this next one, we throw the 6's back up, or the 6 back up and the 12 back up. But notice, I'm not taking the negative with it. Just leave the negative as a subtraction sign, and then we'll use the quotient property in a minute. I think we can condense this all the way down, guys. This is going to end up being log base 7. I can tell there's a quotient component because we have a subtraction. So up in the numerator of your quotient, you're going to have a to the 6th power. But down in the denominator of your quotient, you're going to have b to the 12th power. So this is another good case for you should use parentheses in your logarithm. A lot of kids write this wrong because they put log divided by log, which is not what you do when you condense. So I'm a real big fan of using parentheses around my logarithm insides. Okay, I think it helps. Now let's see some examples that are on your notes. So number 4, we're going to condense this. This is more our PreCalc style. I'm going to pause the video and freeze the screen. I want you guys to try to condense this down to a single logarithm. So you know you're done when you look like this. Log base 9 and then some stuff. Alright, try it. So that's my answer. And I'm not going to show you guys much work because I just kind of hopped to the answer. What I do want to point out to you though, x minus 3 has a quantity surrounded with parentheses to the 11th power, as does 2x. You need to make sure 2x is quantity to the 5th power, or you'd have to distribute the 5th power to the 2 in the x and call it 32x to the 5th. So if you're lazy like me, you just use parentheses and walk away. So let's take a look at number 5. I love number 5 because kids like really freak out, and I kind of freaked out at number 5 at first too because I was like, what? So step back and look at it for a moment. We have 3/4 natural logarithm of 2h plus k plus 1/4 natural logarithm of 2h plus k. Ladies and gentlemen, these are the same terms. So if you have 3/4 of something plus 1/4 of something, and they're the same something, you have one something. So I don't think we need to do any work.
So it just comes down to 1.
It's the natural log, natural log of 2h plus k. And then you're thinking to yourself, it cannot be that easy. There must be some more work for me to do. So then kids try to get crazy, and they're like, it's frozen. Jerk. Alright. Whatever. Okay, so then kids are looking at this and they're going, oh, I'm supposed to like split it up somehow. I don't know what kids are thinking. First of all, the directions say condense, which means you're supposed to bring it to one logarithm and then stop. Children, you have one logarithm. You should stop. There's no way to do anything with natural log of 2h plus k. A lot of kids think they're supposed to separate it somehow. So number 1, that wouldn't be condensing. And number 2, that's also not how the property works. So Hoffbauer wrote a big nasty note right here. It says, natural log of x plus 4 is not the same thing as natural log of x plus natural log of 4. Do not think those are the same thing. It cannot happen. It is totally different. It's an illegal math move, okay? We're going to skip these for the sake of time, and let's take a look at the change of base formula. So I'm about to find out who's a crafty technology user and who is going to be a very sad little pumpkin from Algebra 2. Okay, does everybody know that you have a change of base on your calculator?
No.
Oh, you guys are so sweet. Okay, grab your calculator. Now this is only for the newer ones, TI-84s and above. There's a reason we're having you guys do this on the as a no calculator test. And I'll go into great detail in a moment. But on your fancier calculators.
Algebra students.
Wait, you said this is only on new calculators?
Huh? This is only on, it might be on yours. I think it's 84s and above. I don't know. Just double check. And guys, when I say the change of base button, like, I'm not talking about the change of base formula. We'll talk about that in a minute. If you guys go to math, and you scroll almost all the way to the bottom,
Hey, I got it.
there's something called log base.
I don't have
Whoa.
or numeric solver.
Yes. Now, piecewise and numeric solver are pretty handy too. So when your math teachers torture you with a no calculator test, it's not because we just really love to see you suffer. It's because
We could do that.
half of your SAT test is no calculator.
I didn't know
Your
that.
entrance exams are no calculator. So you have to be able to do them, and I'll show you what they do to you on the SAT, so this is why we're getting ready for it. But, like, I'm sorry, if they're, excuse my language, stupid enough to put a logarithm question on the calculator SAT section, by all means, use log base. Go for it. Like, I'm not going to do that to you because I want you to be able to show me you can do it without a calculator. Yes.
Last year's SAT didn't have it at all. There
They
was
didn't
not
have
a
any
single
logarithm?
Wait, I just broke a rule. No.
And it's the
So if you have the option to use log base, it opens this up for you, and then you can type in whatever logarithm you want.
That's awesome.
Now, some of them are very easy to do mentally, like log base 2 of 4, like 2 to what power is 4? I wonder. Okay, some of them you can't do mentally, but you can estimate them, like log base 3 of 20, like 3 to what power is 20? I don't know, 2 something. Like, I don't know the answer. So I could type it in, what did I just say? Log base 3 of 20. And it'll give me the answer of, that's the answer. Was I supposed to know that off the top of my head?
Yeah.
No. So here's what's going to happen. If you're on a standardized test, and they want you to, oh no, it's disappearing. There we are. And they want you to effectively use logarithms to solve something. What they'll do is they'll leave your answer in like setup form for what's called the change of base formula. This is the change of base formula, and this is what your calculator is doing when you use that little cheater tab of log base changer. And what it does is it takes either a common or a natural log, because those are the two buttons that we have on our calculator, right? Those are the two programmed features. And it does the common log of whatever this number is divided by the common log of whatever the base number is. So, for instance, that one that we just did, which was, I already forgot, log base 3 of 20. Your calculator popped out an answer of 2.7 whatever, but this is what it calculated for you. I don't know which one it defaults to, but it either calculated the common log of 20 divided by the log of 3, common log of 3, or it does the natural log of 20 compared to the natural log of 3. Can you guys do me a favor and type those in your home screen right now and just make sure you do get that same 2.7 whatever. Now, notice you got to close each logarithm, and this is why kids sometimes end up giving me log divided by log on condensing because they get confused with change of base. This is the only time you divide two logarithms is when you're trying to solve. So that's what your calculator's doing. So what you'll notice on like an SAT question or an ACT question is if you get to the point in the math where they want you to do this, they're going to leave, like, choice A will be log 20 over log 3. Choice B will be log of 3 over log 20. Choice C will be log of 20 divided by 3. Like, they'll manipulate the change of base formula setup, trying to trick you, of course, because that's what they do. And they're trying to test whether or not you actually do know how change of base works. Like, any fool can type buttons on a calculator. Should I give them a $10,000 scholarship because of it? No. And they want to make sure that they're giving their money and their college placement to the right kid. So that's why sometimes kids feel like, oh man, they're so mean. They put really nasty things on there. Well, yeah. They've got to, like, rank you from 1 to a million kids, and then they have to figure out who gets their money. So yeah, they're going to make a really nasty test. That's what they do. Okay. So, like I said, in my class, that's why we're giving you a no calculator test, is so you can't use the change of base feature, because I want you to show me that you can evaluate the simple ones without a calculator. Okay, that's the big deal. And then there's a little nasty note here. It says, if I wanted to be real mean, I could lock all of your calculators out. I could put them in what's called test depress mode. And you wouldn't be able to do anything.
Yeah,
You wouldn't be able to use solvers or anything. You wouldn't be able to change it into I mode either. Oh,
yeah,
man.
We can do that to those ones?
Yeah, I did.
Okay, so can we use them? Can we use calculators though?
No. I have to change it to what's called test depress mode. So then I have to update all of your, like, not your operating system, but like the platform it's using. And it involves me hooking up cords. It's a lot of work. I did that one year, and then Hotfire and I decided instead of doing that, we should just ask better questions. So we just ask you better questions now. Or like this case, the test is going to be no calculator. So you're going to be able to show me that you can do it, but maybe you don't have to do it without a calculator for the rest of your life. We get that. Technology, man. It's a thing. Use it. But when it's appropriate. All right. Flip to the back of worksheet 6, please. You're going to see these examples here. Log base 2 of 7. This is using the change of base formula on your calculator. So this is the setup for it. And this is on the calculator itself. But some of us are realizing, oh, that log base changer thing in the math menu is pretty swift. I'm with you. It is pretty swift. I'll be honest though, this is how dinosaurish I am. It's more keystrokes for me to go to math and open up that thing and change the index and everything. I'm much quicker just typing log 7 divided by log 2. But I've also had like many years of doing it that way. So I will tell you, in your upper level math that's to come, you do a lot of work with solving exponential equations and things that involve logarithms to solve. So you have to kind of be swift at using logarithms. And that's coming up in PreCalc as well. And then, of course, in every math class for the rest of your life. So we don't want to be super dependent on our calculators, on the ones that we can do mentally. And we also want to come up with a good way for us to evaluate the nasty ones on the calculator. And I don't know if using the base changer is the best way for you guys to learn it for the future. Okay? Well, the change of base formula, they're the same because what's happening is you're taking the ratio of the logarithms. When we talk about solving exponentials next week or the week after, we'll talk about why this change of base formula works out. I'll show you the derivation of it, and you'll be like, ah, got it. It's just a shortcut. Yes, me. Good? Okay. These three are just, I'm assuming if I gave you guys these, you'd just be cranking them on your calculator, so I'm going to skip them. Let's practice something that would be getting us ready for our no calculator test, though. Can we look at number 9? Can you expand that for me? I'm going to pause the video and freeze the screen. I want you guys to expand that and give me the most pre-calc answer you can come up with. All right, so I told them they should have 2 logarithms, both with coefficients. Did you get that? Ooh, very good. Notice I changed the square root to a 1/2 power at some point in my brain, and then I brought that down in front of his logarithm. Okay.
You split the 3x and the
You did that thing. That super illegal math thing. You can't split the 3x plus 2. So erase that and fix it. See, the one time you take your notes down. Scribble.
Yeah, this is why I'm telling you I
Right.
have to do it in my head.
All right. Well, sure. All right, let's try number 11. I'm going to pause the video. I'm going to freeze the screen. This one you're going to break into not 1, not 2, but 3 logarithms, all of them base 13. Give it a try. So this is log base 13s all the way through. And you should be splitting into 3 different logarithms. Let's see.
Wait.
Okay, don't look.
Tell me I'm not.
You keep looking up at the screen, but you have this problem in front of you, on your notes.
Yeah, if I pulled up.
Oh my gosh.
Okay.
How'd you do?
Extremely well.
Excellent. Okay. So that 7x minus 3, nothing happens with breaking that part up, but the fact that it was cube rooted, which really is secretly a 1/3 power, that came down in front of his logarithm.
Does it matter the order?
It doesn't matter the order. The only important thing is that this guy has a negative or subtraction sign in front of him. You can flip around these if you want. Yep.
But you can't change where that 4 is, right?
The 4 has to be in front of his logarithm, right? I think Jacob's referring to the term order of the adding and subtracting.
Oh, what if I have 4 log 13?
Which sometimes kids get confused on something like 14, where the order's like all screwed up. Notice we have a positive logarithm, a negative logarithm, and then another positive logarithm. So if you were condensing number 14, we have a common log of everything up in the numerator is, let's see, we got a y, we got a 3, and we have a z to the 2nd power. So order doesn't matter so much, but math kind of likes it in this order, But down in the denominator, you've got this guy, which the 1/3 would go up. And I wouldn't write x to the 1/3. What would a pre-calc student write? The cube root of x. There we go. All right. Got page 185 for your homework tonight. Some of it's no calculator. Please follow those instructions.